So welcome to my talk. I'm Pieter Vincken. I'm a consultant with Ordina, and I work since 1.5 years with Alphabet International in Breda. And I'm a cloud automation engineer with a background in software architecture and a software developer. I'm mainly interested in automation and especially interested in using public clouds in enterprises and using hyperscale software like Kubernetes. I'm 29 years old and I live in here in Tals. So what will we talk about today? I will first explain who Alphabet is, show you what the starting situation was, so where did we originate from, what our journey was towards public cloud, and then I will get a bit into the weeds on how you can use Terraform and Kubernetes operators to automate your infrastructure. And lastly, I'll provide you with a takeaway about how to ask for help. You can just post questions into the chat, and if I have time at the end of the session, I will try to answer most of them. So first off, who's Alphabet? Alphabet is the BMW group and is responsible for all of its mobility, or is a mobilities provider for companies and individuals. It's part of the BMW Group Financial Services Department, which means that it needs to adhere to European banking regulations. That will be important later on. And they offer different services like leasing. Some of our Ordina colleagues actually have lease cars from Alphabet, but they are also in the ride-sharing business and even have some specific services like e-mobility, where you can actually get electric cars from them. So what are we talking about today? Today we will talk about the platform that Alphabet is building to adapt to market and business needs. And the platform is meant to support and manage multi-make fleets consisting of passenger cars and light commercial vehicles. The platform should support ultimately, that's not the case today, but it ultimately should support 14 different markets in Europe with and managing over 750,000 cars. So that's a lot of contracts. The idea of the platform is that it would reduce the operational IT cost of the current landscape. So currently, the different markets use different applications and different software packages to actually manage all of these contracts and cars. And the idea is to reduce the licensing cost of those different IT solutions, but also the maintenance and operations of these solutions. So most of the Ordina colleagues will have used the infamous Fleet Agent tool to actually configure their car with Alphabet. And actually one of the applications that will be running on top of the new platform is the replacement of that Fleet Agent, which you can see a screenshot of here. So this is one of the example applications that runs on the new platform. And once Belgium will be onboarded, would run on top of this new platform as well. So what's the starting situation? We were actually the first project within BMW to use their on-premise cloud. So they have an on-premise cloud solution which they provide, which consists out of managed OpenStack, managed OpenShift, and managed Postgres databases. This is, of course, managed by external teams and centrally provided as a standard component, which means that if we want to make changes to it, we always have to submit tickets, which lead to long lead times if we want to make changes to it, if it's possible at all. And we are dependent on the slowest project with regards to upgrade cycles. If one of the projects doesn't upgrade to a new version, then we're stuck on the current version. And over the last year or year and a half, we actually have outgrown the solution, both capacity-wise, due to physical hardware limitations, and due to the upgrade cycle. So the upgrade cycle of the platform is actually too slow for us to keep on using it. And the platform, of course, as you can see, consists out of front-end application and Angular running on OpenShift, back-end applications in Pajara, application server also running on OpenShift, and then some other services like Kafka and Elasticsearch and Prometheus and Grafana running either in OpenStack or within the OpenShift cluster. And everything you see on the picture has actually been migrated over to Azure. So which opportunities did we have by moving to public clouds? We of course, wanted to reduce the operational IT costs. This might sound a bit counterintuitive, but we actually had a reduction in operational IT cost by moving the platform from the on-premise solution into public cloud. Not just by reducing the waiting times and increasing developer velocity, but also just in hardware unit cost as well. So for developer velocity, the main gain was due to the fact that the end-to-end pipelines for deploying to these environments actually was reduced from previously anywhere from 10 to 30 minutes to apply a change to a given environment to just a few minutes, and in some cases even seconds. And we even saw a change in behavior from developers where they would deploy to the environment more often because they could do it faster now. Another reason or another opportunity we had to switch to public cloud was the quality and stability of the platform that we actually had on premise. We had a few production outages which were due to platform instability. As mentioned before, we were highly dependent on the slowest mover to actually update the platform. And we had quite some unstable invented here solutions like the database platform, which is provided by another team, which is not the most stable and the most easy to use in the world, but also solutions that we invented ourselves, like our API gateway, which is kind of an API manager that we created as an entry point into a cluster, which is quite stable, but it's hard to maintain. And lastly, we want to heavily reduce the dependencies and lead times involved with communicating with all these different stakeholders on infrastructure. So for instance, when we want a new database, we don't want to create a ticket and wait 2 weeks to get a database. That should be faster. And the main reason why this is actually not more optimized within BMW Group with the on-premise solution is because BMW's core competence is, of course, not being an infrastructure provider. They're in the car business and they want to provide the best cars, or in the case of Alphabet, they want to provide the best user experience for managing lease contracts. What challenges did we face with moving to public cloud? Probably the most notable one is the operation of public cloud in a regulated environment. Since we are a financial services, are part of the financial services and are handling banking details, we actually need to operate within the European banking regulations, which means that we need to have quite a lot of checks and balances in place. And we have quite heavy policy requirements for our environment to operate. Next to that, we had quite some first mover reluctance since we were the first project within BMW Financial Services to actually move towards public cloud. We had to convince quite some people to actually allow us to move to public cloud, since it was something that nobody had done before within the company. One of the benefits, or the nice things actually, was that we moved from OpenShift to Azure Kubernetes Service. And on paper, this should have been an easy transition. And to our surprise, actually, this was actually also the case. So since we didn't use any OpenShift specific services, the transition from OpenShift to Azure Kubernetes Service was actually quite easy. Since we now are responsible for the infrastructure as well, we needed to, it was quite a challenge for us to adopt that responsibility as well. So now we're responsible for managing databases, for maintaining databases, for keeping the cluster up and running, for making sure that all the components connect correctly together. So this was a new responsibility for us and something that is now part of the product instead of being managed externally. And since we adopted quite some new components, which I will get into later, we also had to learn those components and automate those components as well. Most of our homegrown solutions, like the database system, but also like API management, were completely replaced with managed services from Azure. So how did our journey look? We actually, one of the things that is important to note is that the adoption of public cloud is not just about technology. Otherwise, there would have been one bullet on this slide. But we have actually had a team of 12 people working about 60% on this transition. Since we also need to still support the old platform, we could not spend 100% of our time on it. And we actually started in August of 2019, so over a year ago, with our first proof of concept on top of AWS cloud instead of Azure. And we finally got the organizational green light in June 20. And the actual move is planned for this month. So hopefully within the next few weeks, we will move over our productive environment. And as mentioned before, the move is not just about technology. There are actually 4 big pillars which we saw in our move. The first one, again, and this is a recurring theme in the presentation, is about policy. So the compliance section of our move was quite a big portion of our time and a big investment that we had to make, both to make sure that our checks and balances were in place, but also figuring out what the checks and balances needed to be. Of course, we took the opportunity of moving to public cloud as an opportunity to re-architect some parts of our landscape as well. So we, as mentioned, we replaced, for instance, our homegrown API gateway solution with the API manager supplied by Azure. The biggest one, or the most time spent, was probably on automation. So we automated all of the tickets that we had to create before. We automated the way into infrastructure as code, basically, or pipelines. And last one is one we initially didn't think of as being a big part of our migration, but actually turned out to be quite a big part as well, is actually onboarding developers and ops managers onto our platform. So everybody within the platform team had a very good idea on how the platform works and operates. But once we moved in the first development teams, we noticed that we actually had to educate them, of course, on how to use the platform, which should have not been a surprise to us, but actually was a surprise to us. So I already mentioned that one of the big parts that we had to do was automating our infrastructure. So first off, let me show you what our infrastructure actually looks like. This is an example, or this is a diagram of how one of our development environments looks like. It's not complete, the diagram, but it gives you an insight into how it looks a little bit. So we use the managed Azure API management solution and the Azure managed Postgres databases. And basically all the other stuff lives within our Kubernetes cluster. So traffic flows from the API manager, which acts a bit as our DMZ, into our ingress controller, which is traffic, and then again into our Angular and Pajara services, which again then can connect to Kafka, Elastic, or the Postgres database. As part of the re-architecture, we actually adopted quite some Azure services, most notably the Kubernetes service, of course, which is the beating heart of our solution. But we also took the chance to adopt some other services like Azure Storage Account, which we currently use, among other things, we use for backups of Elastic. So our Elasticsearch instances are now snapshotted and backed up into a storage account, which is a way easier solution than we had before, where we had to store it remotely on some NFS share, which was a nice solution that worked, but it was actually quite hard to properly set up. Another nice thing, which is a nice example of how we automated our infrastructure, is the usage of Azure DNS. Previously, if we wanted to make changes to the DNS service, this would mean a ticket to the DNS team for them to change some DNS entries and to change some IPs. And more often than not, those tickets would be picked up and at least one of those entries would be wrong. So which means that we had to rework again. While now everything is automated with either Kubernetes configuration or configuration within Terraform. So that's a super nice optimization where we gain a lot of time, not just because it's automated, but also because it's consistent now. So how do you provision such an architecture? I actually checked this morning. We actually provision over 900 different resources in our landscape. If you want to do that through the Azure portal, that's super easy to do, but clicking together 900 different resources is not fun, nor is it really agile, really fast or consistent, because it's really error prone. Another solution would be use the Azure CLI, which again is super easy to use. You just install it to run some commands, but we experienced that it's quite hard to do consistently and to set it up properly. And some of the APIs are also not idempotent by design, which means if you run them twice, you get different results, which is not desirable in automation. And as any good project, we onboarded an expert then to actually come up with a solution for this. And we looked into Azure resource managers, so ARM. And actually, we tried out the solution quite extensively, but due to the fact that we don't control all parts of our architecture, for instance, all the networking and Azure Active Directory stuff, we don't control. And therefore, the solution didn't work because we didn't have full control over our landscape, and the ARM templates didn't really play nicely with that. So that introduces Terraform. So for those who don't know, Terraform is a solution or a software package created by HashiCorp. It's a descriptive language for describing desired state of your infrastructure. And as any good software project, we didn't build one version of our Terraform setup, but we built 3. And again, as any good software project, we started out with a monolith. So we built one big mono repository where everything, all the Terraform code was stored. All the components all the infrastructure components we had were scripted in there. And we added code for provisioning those services, for configuring those services, and for configuring application landscape resources. So everything was grouped together in one big repository, which meant that it was super easy to add code or to change code, because everything was just in one location. You could just run one pipeline, which was easy as well. And it was at least repeatable, automated, and it was infrastructure as code, which means that it's reviewable. And the automation we attached to it, so the Jenkins pipeline that's attached to it, actually made sure that we also had the Terraform plan, which is actually a comparable to the diff that Kevin showed in the previous presentation, where you can see what changes your Terraform will actually apply to your infrastructure. A big problem we had with this this monolith is that we had a couple of timing and dependency issues. So more often than not, we had to run the pipeline at least twice to get a successful build or to get this successful rollout. We also needed a lot of rollouts because we made changes to the configuration of our API manager quite often. For instance, if we would deploy a new app to a new environment, we would have to change API manager configuration, which meant that we had to trigger this Terraform rollout. Since all that configuration lived in that one repository, there was a lot of copy paste as well. So if you wanted to add an endpoint again, you would copy a previous endpoint, change the endpoint name and the endpoint where it needs to point to. And if you would have to create updates for all of those components at once, then you would have to change it in maybe 50 different places, which makes it really hard to upgrade. So again, we followed the perfect pattern of a software solution. So you build reusable components next. And so we built opinionated modules for each component. So for our Kubernetes cluster, we created a component which has all the configuration connected to Kubernetes. The same for Key Vault. We added all the configuration for Key Vaults, including the certificates and keys and secrets that it would keep all into one module. And then we created those modules and added them to repositories. One repository for actually provisioning infrastructure, so that means spinning up hardware, and one repository which only contained the configuration. This made it possible for us to actually split those slow infrastructure pipelines out of the configuration pipelines, which we had to run often. So the configuration ones we had to run often, and infrastructure ones wouldn't change as much, but they would be slow to run. So that's quite a nice solution. And we duplicated this setup for every single environment we had. So the benefits are that we now have easy reuse because we could easily reuse those modules across different repositories. Our services, our provision services would not break as often. So in the previous state, we would have issues where, because we had to run the pipeline multiple times, the first time it would fail most often because the configuration was changed while the infrastructure was still provisioned. And of course, we had faster rollouts of that configuration pipeline because it just had to process less. One of the things we unintentionally introduced is, of course, a hard dependency between those two pipelines, between the infrastructure and the configuration pipeline. Because if you run the infrastructure pipeline, or you make changes to the infrastructure pipeline, it's highly likely that you have to run the configuration pipeline as well to have a consistent state. And still, we had to have a lot of runs of that configuration pipeline because still every single time a new app gets deployed, we had to run it the pipeline to add the new API configuration. And one of the things which is not technical, but more organizational, is that it's hard to determine what configuration should be where, right? How do you determine if something is an infrastructure or whether something is configuration? So this was still not an optimal solution. So then we went to our final setup, or our current setup. I don't think it will be final, but it's our current setup, where we basically threw out all of our configuration repository. So all of our configuration was removed from our Terraform setup and moved into something else. I will explain that later. And we created the modules in such a way that they would deploy the component they described in a safe and compliant way, but only that would be in. So no additional configuration would be in, just the configuration to get that component up and running in a safe and compliant way. All of our modules are versioned now as well. So that means that we can more easily roll out specific versions on specific environments. And we created so-called meta modules, where we actually included modules and modules to make even more higher level abstractions that we can use. One of the nicest things we did, in my opinion at least, to the setup was we added a nightly regression test, which in our case means that we deploy our previously known good Terraform state to an environment. We test it by using application landscape tests. So we validate that it works. Then we apply our new configuration, so the configuration we built today, for example. We deploy it to that environment, and we again run the same test. So then we have tested that our increment works, so that we could easily update the other environments. And then we destroy that complete test environment, and we rebuild it from scratch to, again, validate that we can actually rebuild it from scratch as well. And once all those tests succeed, then we accept that that's our new stable Terraform state and our new stable Terraform set of components that we can roll out. This has a benefit that all of our rollouts are proven, so we can actually prove that our set of components works. The incremental changelog is available as well, because we now version our modules. And common changes are easy, because we can just make a small change in one of the modules, update the update the repository that contains the testing infrastructure code, and then we just roll it out and see if it works or not, because it can be easily tested. One of the things that's still hard to determine is what to actually test. Currently, we just run application landscape tests, which means that we spin up everything and then check if we can log in and perform some actions within our application landscape. But we would prefer actually to be a little bit closer to the actual infrastructure and to see if we can actually test the infrastructure being there. So on to the next part. I mentioned that we removed all the configuration. Of course, you need to have that configuration somewhere. And we actually removed that completely from the Terraform setup and moved it into operators. And these operators are not the people you call at night when your cluster is down, but these are actually Kubernetes operators, which allow you to extend the default Kubernetes behavior with some custom code, basically. So as mentioned, one of the problems we had was syncing our API manager configuration to our, so the user actually enters our platform through the API manager. And from the API manager, we route the traffic into our cluster, into our ingress controller. And that directs our traffic then again into our actual service running our Pajaro application or our Angular application. In order to do this, we actually need to add OpenAPI specifications to our API manager in Azure. But we also need to tell our ingress controller how to route the traffic within our cluster. And these actually are two different specifications which are highly similar and which we needed to keep in sync in phase 2 of our Terraform setup. We had to keep those in sync manually, meaning that if we deployed a new app, we needed to create some new OpenAPI specification, and then we would run our pipeline, and those two would be active. If one of the two would not be in sync, we would not have traffic flowing from the user into our cluster. So what we did is we, of course, automated that. And since the configuration for our ingress controller was closest to our actual service because it was deployed as part of our service. We actually took that as a single point of truth. And we created an operator which watches those Kubernetes configurations and actually automatically generates those OpenAPI specifications and submits those to the API manager, meaning that the flow would be automatically updated once the ingress routes are deployed. So next to the API manager, which was built on top of the COP framework, which is a Python framework where you can tell the framework I'm interested in these type of resources, and then it just triggers a bit of code, or you get a callback every single time that something changes there. We actually built a second operator as well, which is called environment initializer, which basically creates some RBAC configuration and some the CI/CD integration every single time we create a new namespace. And this one is actually even easier to build because it's built on top of the shell operator, which means that you can just specify a bash script, which is triggered every time something changes in these resources you're watching. Of course, we're not the only ones who are building operators. There's a lot of operators available in the open source. I would like to highlight some of those. One of the operators we use, actually combined with others, is the Azure AD pod identity, which is a super nice operator which allows you to add managed identities to your Kubernetes cluster, meaning that you don't have to manage service principals, which are technical identities. Basically, there are usernames and passwords for your technical accounts. You don't have to manage those yourself within your cluster. So you just tell the pod identity that it can authenticate to the Kubernetes, to the Azure API. And it will provide identities to whatever workload you're running in your cluster where you request an identity. So for instance, our external DNS operator, which is another one we use, uses this pod identity to authenticate to the Azure API. So once the external DNS is deployed, it has a identity connected to it, and it can automatically authenticate to the Azure API without us having to add any credentials or manage any secrets or manage any login information. The external DNS operator in itself actually manages all those or parts of our DNS requests, as I mentioned earlier. So for instance, once we deploy a ingress controller in our cluster, it will automatically get a DNS nice name submitted in the Azure DNS zone of that cluster, which means that the API manager can automatically connect to that ingress controller directly through its nice DNS name. So that makes our life a lot easier instead of having to manually update those. Another really nice operator is the last one actually on the right here. It's called the logging operator by Banzai Cloud. And that's an operator that makes your life with regards to shipping logs somewhere super easy. So it deploys all of the fluent D and fluent bit stuff in your cluster automatically based on some configuration. And the only thing you need to specify is where you want to ship your, which logs you want to scrape. So which pods should be included and which should be excluded, and where you want to send it. So in our case, our first solution was to use Loki by Grafana as a dump of our storage location for our logs, which meant that we created one Kubernetes object, which just specified that the logging operator needed to ship everything to that endpoint. Later on, we actually deployed Elasticsearch as well into our cluster and Kibana. And we actually just had to make one additional Kubernetes object in our cluster in order to allow the logging operator to ship the logs to that second logging sync as well. So my last takeaway, and this is probably the most important part of the entire presentation, is asking for help. Normally this is really applicable within your team itself, but if you move to public cloud, it's actually really important as well to do this for external people as well. For instance, we reached out to Microsoft and actually had them review our architecture and actually help us guide, or they guided us into how to set. They also provided roadmap insights for example, we have the requirement to encrypt our Postgres databases with our own custom key. This was when we started with with looking into the migration. This was not supported at all on the Microsoft platform, and we were looking into whether we should enable that ourselves or implement that ourselves for Postgres, or whether they could supply that. And by talking to them, we actually figured out that this was on the roadmap for the next 2 to 4 weeks when we requested this the first time. And actually they delivered that within, I think, 2 or 3 weeks later, that the feature was available and we could use it. So that was super nice that we could get an insight there, and it prevented us from having to do that work ourselves and having to re-architect it later. Another nice way to ask help from Microsoft, they're really helpful, is to supply feedback on missing features. They have quite a lot of public GitHub pages where you can submit feedback. And if you have contacts within Microsoft, you can even ask them to prioritize some of the issues to get those issues implemented if you're waiting on that, or whether if that's blocking you from moving forward. We did that, for instance, on some Terraform issues, where we, for instance, with the bring your own key for Postgres, this was supported within the platform, but not yet in Terraform. And then we asked them about when that would be implemented, and literally a week later, they had completed that request and actually merged it into the Terraform provider. So that was super nice. Next to Microsoft, probably even more important, is reach out to your internal or external auditors to get the requirements for your checks and balances that you need to apply to your cloud environment upfront. So we actually got a checklist from our auditors where they stated you need to enable these controls on your landscape, and you need to be sure that these checks and balances are in place. And because we knew that upfront, we could actually architect based on those checks and balances instead of having to re-architect later, which means rework. So that was it's a real, I cannot stress that enough to reach out to them instead of doing it afterwards or trying to get rid of some of the audit requirements. Just get them up front and architect for the requirements. And then the last one, get feedback from your customers. In our case, we're a platform team, so that means that our customers are our developers, and actually some of the Ordina colleagues are our customers. Get feedback early. So once you have something working, we probably did this a bit late in our project, but once you get something working, get them to use it and figure out what their most important missing feature is. For example, we had a logging solution, as I mentioned, Loki deployed in our Azure stack, and actually deployed that as part of our re-architecture. And but this actually didn't fit our developer workflow. So we had to change it back to Elasticsearch and had to deploy Elasticsearch again in the cluster, which was fine, but it was actually something we didn't foresee up front. So now we'll try to answer. By the way, these are the people of the Unicorn team of the enabling area, which actually did the migration or built the migration over the last year. Now we'll try to answer any questions you have, and we'll thank you for your time. So Jolan posted, how did you convince business to go from on-premise to public cloud? Was it your or their suggestion? So it was our suggestion to move to public cloud, and the main driver was actually cost. So as I mentioned, we actually reduced the cost both in developer time, but also in hardware units cost. And next to that, there's actually an executive, or how do you call it, a strategy from BMW Group to actually try to adopt as many of the public cloud solutions that they can, so they don't have to be an infrastructure provider themselves. Because again, BMW is in the business of mobility and of building cars. They're not in the business of being the best infrastructure provider they can be. Any other questions? I don't see any popping up in chat, so okay, I will thank you for your time, and then we have a small break, I think. Kevin?
Yes, that is correct. Thank you, Peter, for your talk. Yes, we now have a small break until 10 past 4, when we will pick up with the last session, Some Pitfalls of AI by Joachim Gansemann.